Today we are going to start aldehydes and ketones. These are also called carbonyl compounds. Question number 1, class work from aldehydes and ketones. Convert acetaldehyde into the following compounds. This is subjective type question, no options. To revise our subject properly, we should do this type of conversion type questions. Acetaldehyde should be converted into this compound. Let us take acetaldehyde, CH3COH. So what we have to get? CH3, CHBr, single bond, again CHBr, COOH. So compulsory 2 acetaldehyde molecules must be taken. This is very logical question. 2 acetaldehyde molecules we have to take. Two carbons must be added by the removal of oxygen. After that, we have to add 2 bromine atoms. How can we combine 2 carbons of 2 aldehydes? We know aldol condensation. So when it is subjected to aldol condensation by treating with sodium hydroxide dilute, followed by heating via aldol, what happens? 2 carbons get combined each other. Alpha beta unsaturated aldehyde is obtained. So how to write direct condensed product? I will give the technique. CH3 CH double bond O, you write like this, and you display 2 alpha hydrogens of next molecule. So 2 molecules undergo condensation. You remove H2O. After the removal of H2O, you combine alpha carbon with carbonyl carbon. You can get alpha beta unsaturated aldehyde. Okay. Crotonaldehyde. Alpha beta unsaturated aldehyde. Then what you have to do? 2 bromines we have to add. At the same time, CHO should be converted into COOH. So first we will oxidize the CHO by using oxidizing agent. Here better oxidizing agent is Tollens reagent or Fehling's reagent. Then only we can oxidize aldehyde group without disturbing CC double bond. So what we have to do? CH3, CH double bond, CH remains present. CHO will be oxidized to COOH. Next to target, in place of pi bond, 2 bromines must be added. Bromine in the presence of CCl4. 2 bromines are broken. Anti-addition takes place, I think you know. Addition of bromine. Anti-addition. 2 bromines are attached from different directions. Bromine from above, other bromine from below. So this is the product of it. Okay. First, acetaldehyde is subjected to aldol condensation to get condensed product, alpha beta unsaturated. Then oxidation of CHO into COOH by Tollens reagent. Then addition of bromine. Okay. So logical thinking. So you are applying many concepts, you know. So many concepts we are revising. Aldol condensation concept is revised. oxidation by Tollens reagent revised, electrophilic addition reactions of alkenes revised. So unless you apply these three concepts, you cannot complete the task given. Right, next one. Name the following reactants. Name the following reactants and also give the names of reactions involved. So here we got formate and methyl alcohol. One is carboxylate ion, another one is methyl alcohol. It is very easy Kenizerose reaction. During the Kenizerose reaction, what happens? Two molecules of formaldehyde. Two molecules of formaldehyde in the presence of concentrated alkali undergo disproportionation. One carbon undergoes oxidation, other carbon undergoes reduction. Okay. So oxygen is inserted. One is undergoing oxidation. Other carbon is undergoing reduction by the insertion of two hydrogens. One at oxygen, one at carbon, methyl alcohol. As the reaction is carried out in alkaline medium, the formed acid will not exist as acid. So finally what happens? So here formic acid is formed as an intermediate only that undergoes further neutralization to give formate ion. Right? So the final products are formate and methyl alcohol. That's why A is formaldehyde. The name of the reaction is Kenizerose reaction. When this is reacted with NBS, we know NBS, N-bromosuccinimide. NBS is nothing but N-bromosuccinimide. N-bromosuccinimide is a specialist reagent. N-bromosuccinimide is a specialist reagent used for the bromination at allylic carbon or benzylic carbon. Okay, allylic carbon or benzylic carbon. So benzylic bromination or allylic bromination is done by using NBS. First 2 moles they mentioned, 2 equivalents of NBS when compared with 1 mole reactant, 1 equivalent reactant. So here benzylic carbon is doubly bonded carbon. That's why you see the allylic carbon. The CH3 carbon is allylic carbon. So during the bromination, allylic bromination is preferable. So in the first step, what happens? Allylic bromination takes place. Monobromination. CH2Br. 2 NBRs are mentioned, NBS mentioned. No? That's why 1 more bromination. CHBr, Br. After that, hydrolysis. During the hydrolysis, what happens? 2 bromines are replaced with 2 H groups. Gem-diol is obtained. Gem-diol is obtained. We know gem-diol is highly unstable. As soon as it is generated, it will undergo dehydration to give corresponding carbonyl compound. C double bond O H. Here H. So this is the final product. Cinnamaldehyde. This is cinnamaldehyde. So where is the correct answer? C. C is the correct answer. Next one. Identify the reactants. A is the sodium salt of carboxylic acid. Example. RCOOH is the carboxylic acid. Sodium salt of carboxylic acid, how can we represent RCOONA? Sodium salt of carboxylic acid is used for the treatment of A, that gives the product. This one and this one. So what might be the reaction? Intramolecular Perkin reaction. Intramolecular Perkin reaction. So before that, we should know what is Perkin's reaction. Important reaction. Perkin reaction. Suppose benzaldehyde is there. When benzaldehyde is reacted with anhydride, okay, sorry, anhydride. Let us take acetic anhydride. This is acetic anhydride. In the presence of sodium salt of same acid, acetic anhydride is obtained from acetic acid, no? So you have to take sodium acetate. In the presence of sodium acetate. So what will be happen finally? I'm not giving total mechanism. 2 hydrogens and 1 oxygen you remove, like Caldwell condensation. pH, CH double bond, CH, COO, COCH3. Then hydrolysis takes place. You can get this acid, alpha beta unsaturated acid. Nothing but cinnamic acid here. Cinnamic acid. Intramolecular Perkin reaction. Now we will use the concept of intramolecular Perkin reaction. So the product obtained from A, we are getting the product, you observe. Between alpha and beta double bond is created, no? In Perkin reaction. You observe, no, just now. Between alpha and beta double bond, alpha beta unsaturation. So this is the product during the intramolecular Perkin reaction we got. So what we have to do to get A, to get A, what you have to do, just you break the CC double bond present between alpha and beta. So one will become aldehyde, other one will take alpha hydrogens, no? So how to guess? Vinyl group, here CH3. Yes. This will be CH2, COOH. This side C double bond O. Benzaldehyde, no? Like aromatic aldehyde. But this is obtained after the dehydration, hydrolysis. So what we have to do? It should be converted into anhydride, no? See, aldehyde without alpha hydrogen plus anhydride must be involved in the Perkin reaction. So CH2CO, OCO something. So this part will be converted into acid, no? So along with this, what is the acid given in the question, no? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Pentanoic acid is given. Along with this pentanoic acid. So better you take this side, pentanoic acid. CO, one here. CH2, 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 CH3. 1, 2, 3, 4, 5. Yes. This is the given one. This should be A. Compound A. Finally, observe. Methyl here. 1. 1, 2, 3, 4. Yes, this is compound A. Now, again take the question. This is A. Subjected to Perkin reaction. Sodium salt of carboxylic acid. At this time, sorry, here CHO. This is A. When it is subjected to Perkin reaction, what happens now? Oxygen of the CHO get combined with 2 alpha hydrogens. Then double bond is created between those two. Yes. Between these two newly double bond, no? 2 bonds like this. Okay. Methyl here. This side double bond O, CO, 1, 2, 3, 4. Then hydrolysis. During the hydrolysis, this part will become acid. This one. Then other one is pentanoic acid. 1, 2, 3, 4, 5. This will become pentanoic acid. So what you have to do, you break this double bond. You make this one as aldehyde, and this will be converted into anhydride by combining these two acids. You will get A. Otherwise, in the examination, they will give 4 options. No? As capital A, you take option A and you try. If it gives these two, that is the answer. If not giving, go for B and check. Not giving, go for C. If these 3 are not giving these 2 products, the answer definitely D. This is called hit and trial method. Okay, children, next. Allyl bromide, when it is reacted with magnesium in the presence of ether, followed by benzaldehyde, followed by hydrolysis. What are the products? What are the products? Okay. First, Grignard reagent, formation of Grignard reagent. This is one. First one. Then it is subjected to nucleophilic addition reaction with acetaldehyde. The carbon holding magnesium is nucleophilic carbon because of higher electronegativity. This carbon attacks at electrophilic carbon, that is carbonyl carbon, undergoes nucleophilic addition reaction. So the product, it becomes C single bond O. O takes H plus later, becoming OH, CH, CH3. That is one, right? So where is the star symbol? Allylic carbon is the star symbol. Then this will be the allylic carbon. Otherwise, one more option. This allylic group may be undergo rearrangement. C double bond C. This is starred allylic carbon. Br. This bond is highly polar covalent. That's why what happens, allylic group will undergo rearrangement like this. So MgBr may be attached with this side. At this time, double bond here, star symbol to the vinylic carbon. So two types of allyl bromides are possible. Magnesium MgBr attached to starred carbon once, unstarred carbon bonds. Okay. So if you take this Grignard reagent, this will be the product. Sorry, this is benzaldehyde. No? I wrote CH3 here. Sorry, pH. Okay. B is obtained, A also obtained. Since allyl bromide is having two resonance structures. Two types of products are obtained. So A and B both are correct. That's why C is the correct answer. So already I told, whenever both option is there, all option is there, you have to take care. Most chances will be there for those options to become correct answer. So here the concept of two resonance structures of allyl bromide. New point you got here. Allyl bromide can exist as two resonance structures. That you have to remember. Next one. Identify the following disproportionation reaction. Disproportionation reaction. Canizerose reaction. This is one taken. So this is very, very important question actually. Better we will use whiteboard. H CO D, right? One is heavy hydrogen, other one is normal hydrogen. 2 out of 2 such type of molecules. Formaldehyde, deuteroformaldehyde. Mechanism we should know. So observe the mechanism. first OH minus. OH minus normal only, no, not OD minus. First step, OH minus attacks at electrophilic carbon, carbonyl carbon. Pi electron pair is shifted on to the next one. So we can get HCO minus OH D. That is the first step. The second step, what happens? Second step is the rate determining step. What will be happened during rate determining step? Lone pair of O minus is dropped between C and O. Carbon pushes the hydrogen out. Which hydrogen comes out as H minus? That is important here. In between CH and CD, CH bond is weak when compared with CD bond, no? So H is expelled out as H minus. Hydride shift takes place, not deuteride. That you have to remember, children. H minus is shifted. Okay. This is rate determining step, slow step. So DC double bond OH, left side one. Right side one will become DCH2 O minus, right? Then the next step, what happens? O minus takes H plus from OH group of the next acidic group. O minus. Okay, simply you remember as H plus transfer. So the final products are nothing but DCOO minus and DCH2O minus. These are the products. DCOO minus, other one DCH2OH we got, no? You check. So if you know this mechanism, you can perform the remaining questions. I hope you are able to do. But perfectly you should know the mechanism. Okay, children, coming to class 8. Observe. Compound A given below can undergo Cannigerose reaction itself and crossed Cannigerose reaction with formaldehyde. It is because of. So the given compound undergoes Cannigerose reaction and crossed Cannigerose reaction with formaldehyde. What might be the reason? Cannigerose reaction between two aldehydes without alpha hydrogen. Crossed Cannigerose reaction means those two aldehydes must be different, like formaldehyde and benzaldehyde. In both of the aldehydes, alpha hydrogen should not be there. Reasons, you say, expect the reasons. It has 3 CH2OH groups. Is it correct? Has 3 CH2OH groups. Check where are the 3 CH2OH groups. CH2OH, what is the next two? It has 3 CH2 groups. It has an aldehyde group. Correct. It has a non-enolizable alpha carbon. So non-enolizable alpha carbon means alpha carbon should not have alpha hydrogen. Enolizable alpha carbon meaning, suppose one hydrogen is there, alpha hydrogen. So what happens? Then we can get enol form. C double bond OH. Like the enol form we can get. So this is called enolizable alpha hydrogen. In this compound A, alpha carbon, so this is alpha carbon. There is no alpha hydrogen. Enolizable hydrogen is not there. That's why it undergoes zero reaction. That is the main reason. It has non-enolizable alpha carbon. Alpha carbon without alpha hydrogen is called non-enolizable alpha carbon. So that is the main reason, right? Reason they are asking. It has 3 CH2OH groups. Don't get confusion. It has one aldehyde group. But what is the question? Because of which reason this molecule undergoes self-aldol, self-Kennegerose reaction as well as cross-Kennegerose reaction with formaldehyde. That is due to lack of alpha hydrogen. Alpha hydrogen is also called enolizable hydrogen. So reason they are asking, that's why answer is C. You may think B also correct, A also correct, but they are asking the reason. Reason is this one. Why it is undergoing self-Kennegerose reaction and cross-Kennegerose reaction. Okay. Right, now next one. Which of the following sequence of reagents is correct in the conversion of A to B? Which is the correct? So first you have to observe which is A, which is B. We are getting cyclohexane. So what might be done? OCH3 must be decomposed. 2 OH groups must be formed. Then it becomes gem diol. Gem diol undergoes dehydration. Okay, children. First hydrolysis. So during the hydrolysis, here also what happens? Ester bond undergoes hydrolysis to give gem dioic acids. No? Gem dioic acid. Gem dioic acid just by heating undergo decarboxylation. So hydrolysis followed by decarboxylation should be happen. Now you check the reagents. A, sodium hydroxide reflux, next soda lime. Aqueous HCl reflux, soda lime. Compulsory heating symbol should be there. Okay. Compulsory heating symbol should be there. Then only decarboxylation takes place. So, soda lime heating compulsory. You can eliminate these two options. Next one. Alkaline hydrolysis or hydrolysis in the presence of acids. That also important. Both should be hydrolyzed, no? So, acidified hydrolysis is suitable. So, in the presence of HCl, aqueous HCl, if it is subjected to reflux, in the presence of aqueous HCl subjected to reflux, what happens? Here it undergoes hydrolysis to give gem diol. It undergoes hydrolysis to give gem dioic acid. OH, OH. Here COOH, here COOH. So ether and ester both should be undergoing hydrolysis. That's why hydrolysis in the presence of HCl is suitable. Then on heating, what happens? Since this is gem diol, undergo dehydration. This is gem dioic acid, undergo decarboxylation. At the same time, it should be subjected to decarboxylation by using soda lime, NaOHCaO. During the another gem dioic acid undergo decarboxylation to give monocarboxylic acid. That also undergo decarboxylation by using soda lime. So the correct reaction sequence: aqueous HCl reflux followed by heating with soda lime. Okay, next one, no? Classwork 10. Isopropyl alcohol on mild oxidation gives X. X with methyl magnesium iodide followed by hydrolysis. So in this sequence of reaction, what is Y? First, you take isopropyl alcohol. This is isopropyl alcohol on mild oxidation. So during the mild oxidation, what happens? Mild oxidizing agents like PCC, PDC must be used. These two hydrogens get combined with oxygen, forming H2O. So isopropyl alcohol loses two hydrogens undergoing oxidation to give acetone. Acetone is X on reaction with methyl magnesium iodide. So here methyl acts as attacking nucleophile, attacks at carbonyl carbon, 5 electron pair is shifted onto O. Then we can get O minus here, CH3. Tertiary butoxide, right? Tertiary butoxide on hydrolysis. This is a salt actually. Tertiary butoxide on hydrolysis takes H plus. Okay. Yes. This is the answer. Tertiary butyl alcohol. Sorry, tertiary butyl alcohol is correct answer. Where is that? C. C is the correct answer. Next one. Which of the following ketone will not give yellow precipitate with sodium hydroxide and iodine? Yesterday also I explained what type of compounds will give iodoform test. Alcohols containing beta methyl group. Beta carbon of alcohol must be methyl. Otherwise, you remember the alcohol with this group, with the structure, undergoes iodoform test. Otherwise, aldehyde or ketone containing alpha methyl group. This compound contain aldehyde or ketone containing this group also will give iodoform test. So you check 2-pentanone, CH3, CO, CH2, CH2, CH3. So because of this group, it gives iodoform test, no? Will not give. One more thing, not. Very dangerous, this type of question. Not, incorrect, wrong statement. Such type of questions are very dangerous. Better you round up that not. You should focus on wrong statement. A is the right statement. Then benzophenone. We should know what is benzophenone. This is benzophenone. How it gives iodoform test? No? Wrong. It won't give iodoform test. Okay. It won't give iodoform test. Acetone, Pawan, when did you join? Okay, your exam got over. Very nice. How did you write? First exam in your life. Okay. Here. Superb. Very good, Pawan. How is the chemistry paper? Total paper, how is the paper? Easy, huh? Very good. Then first time you are attempting entrance examination towards your future engineering. First exam, no? Then what about our chemistry? How is our chemistry, ma? Chemistry easy? Moderate. Okay. From aldehydes and ketones, any question you got? Aldehydes, ketones, alcohols, alkyl halides. Any question? Haloalkanes you got. Based on elimination, substitution reactions. 3 questions you got from haloalkanes. Very good. I hope. So I think based on the mechanisms only. Elimination reaction, substitution reaction, and very good. So what we are doing here, what we are predicting, in which concept we are concentrating, I think you got questions from those only. Am I correct? Where we are concentrating, from that only you are getting the correct answer, right? Yes, once, wait. Pawan, wait, unmute yourself and talk.
Hello, good afternoon, sir.
Good afternoon, Pawan. How are you, ma? Too much excitation I am observing in your voice.
Yes, sir.
Which is your timings? Pawan? In which slot you wrote exam? Hello, Pawan? Hello, Pawan? Hello, Pawan? Not audible. You are not audible. You are in excited state. You wrote the exam JEE main very well. I know. I hope you can get good rank with this performance only. From first attempt only, you are going to get very good rank. You will be selected for NITs at least. Okay, one more student also joined. Ashwath Reddy. Ashwath Reddy, welcome. How did you write the exam?
Hello, sir.
Ashwath Reddy, unmute yourself.
Hello, sir. Am I audible?
Okay, Pawan, some network.
Yes, sir.
Pawan, some network issue is there.
Yes, sir. Little network issue from me.
Ashwath. Okay, ma. Okay, no problem. I came to know that Pawan, you wrote very well.
Yes, sir.
With this attempt only, you will get at least NIT.
Yes, sir. Hoping for the best, sir. Yes, sir.
Yes, definitely. We will pray for you.
Sir, I had a doubt in chemistry, sir. I had a doubt in chemistry.
Yes. You can reach out to me at any time. You can WhatsApp the questions.
Sir, now itself, sir, a small question.
No, no, we have to do aldehydes, ketones. We are in the middle. 11th question only we did. One more day is there, but some questions left over in alcohols, phenols, and also alkyl halides. Okay, let me know Ashwath Reddy. Ashwath Reddy, how did you write now?
It was fine, sir.
Ashwath?
Hello, yes, sir.
Very
Sir,
good,
can you
very
hear
good.
me?
Yes.
Yeah.
How is the paper?
Sir, physics
Ashwath,
was easy. Physics was easy.
Okay. Chemistry?
Chemistry from NCRT, sir.
Very good, very good. Many times I told NCRT, moreover, exemplar problems you should follow.
Yes, sir.
You got the questions from exemplar problems, models at least.
Yeah, yes, sir.
Okay. Overall satisfaction. You
Yes,
have good
sir.
satisfaction or about the
Yes, sir.
very, very good, Ashwath. Then next month only, again.
Yes, sir. A March attempt.
Yes. So do concentrate.
Yes, sir.
On the present topic going on. Okay, na?
Okay, sir.
So, right, Ashwath.
Yes, sir.
Listen carefully. Pawan, doubts
sir.
you can reach me on WhatsApp because many questions are there in this chapter also. Because other students are also watching recording videos. So we can't waste the time here.
Yeah, sure, sir.
Later you can send the doubts to me.
Sure,
okay?
sir. Sure, sir.
I will clarify personally.
Sure,
Right,
sir. Thanks a
Pawan.
lot, sir. Thanks a lot.
Right. Okay, children. Happy by hearing some students. They got very well. They did very well in the examination. I hope they will get NIT seat at least under any circumstances. Right. Continue with classwork 11. We did no benzophenone won't give iodoform test. That's all. Answer is good. If it is multi-answered, better you check others also. Acetone, CH3, CO, CH3. Because of this group, it gives iodoform test. 2-hexanone, any 2-ketone will give the iodoform test. So D also will give the iodoform test. Only B won't give the iodoform test. Okay, next one. The reaction between carbonyl compound and alpha bromo esters in the presence of metal zinc. This is almost direct question. To give beta hydroxy esters. Beta hydroxy ester is known as. Otherwise, if you are unable to remember, you can select the elimination method. Not Grignard reaction, not Wolff-Kishner reduction, not Clemenson's reduction, right? These two, Grignard reaction, we know. So where is the answer, ma? Reformatsky reaction. Aldehyde without alpha hydrogen, when it is reacted with alpha bromo esters in the presence of zinc. Finally, after hydrolysis and heating, we can get alpha beta unsaturated acid. That is nothing but Reformatsky reaction. Okay, coming to the 13th one. A compound has the molecular formula C6H12O. C6H12O. So, its formula is indicating CnH2nO. With this formula, we can get aldehydes or ketones only, no? Aldehydes or ketones. General formula of the aldehydes and ketones CnH2nO. Now, C6H12O. It does not reduce Tollens or Fehling's reagent. Does not reduce Tollens reagent or Fehling's reagent. So, what is the meaning of keto group? It is nothing but a ketone. Next, another hint. This is hint number 1. Second hint, it gives crystalline derivative with 2,4-dinitrophenylhydrazine. Second hint indicates as it is carbonyl compound. Carbonyl compounds can react with 2,4-DNP to give a crystalline derivative. No? That is second hint. Third one, with alkali and iodine means iodoform test. This is the third hint. It gives yellow colored precipitate, which has what is it? Medicinal odor. CHI3, no, yellow color precipitate is nothing but CHI3. So since it is giving iodoform test, it should have CH3CO group. Right side C compulsory. Then again, another hint. Clemmensen reduction converts it to 2-methyl-pentane. So during the Clemmensen's reduction, what happens? C double bond O will become CH2. So CH3, CH2, 2 CH2, CH2, CH, CH3, CH3. We know. 2-methyl-pentane we know. Right? So in place of these two hydrogens, earlier oxygen was there. The structural formula of the compound is most likely this one only, no? Structural formula. So what is the structural formula? CH3CO, CH2, CH, CH3, CH3. Since it is ketone, it won't undergo, it won't react with Tollens reagent or Fehling's reagent. With alkali and I2, it gives iodoform test. Because of the Clemmensen's reduction, double bond O is removed and 2 hydrogens are added, then we can get 2-methyl-pentane. So based on the hints, we can expect the product. So what is the answer? 1, 2, 3, 4, 4-methyl 2-butanone. 4-methyl butane 2-one is the product. Okay, here options are given. I did not see. Sorry. Where is the correct answer, ma? 4-methyl 2-butanone. You see the option A. Option A only correct, no? CH3CO. This is 4th carbon. At 4th carbon, methyl, methyl. So 4-methyl 2-butanone. Next one. This is cinnamaldehyde. On treatment with eggs, it undergoes reduction. Double bond remains constant. So the reducing agent should not affect the CC double bond. What is that reducing agent? Hydrogen in the presence of nickel. Hydrogen in the presence of nickel can reduce even CC double bond, right? It can reduce even CC double bond. But CC double bond should be there. So what is the correct answer, ma? Sodium borohydride. This is oxidizing agent. Wrong, wrong, correct. Yes, Pavan. Right, next one. In order to prepare acetone from acetyl chloride in one step, which of the following reagents will be the best? To prepare acetyl from acetyl chloride, this is acetyl chloride, no? In one step only, we should get acetaldehyde. Yes, very good, Pavan. You don't know Monday, Tuesday, how I taught. No response. CH3COCl get reduced to CH3CHO. If it is hydrogen in the presence of palladium, what happens? The formed acetaldehyde, which is formed as an intermediate only, just intermediate, undergoes further reduction to give ethyl alcohol. No? That's why to control the reduction process, the palladium is subjected to poisoned with barium sulfate, Lindlar's reagent. So in the presence of barium sulfate, what happens? The reaction will be stopped with acetaldehyde only. Stopped with acetaldehyde only. That is nothing but Rosenmund's reduction. Acid chloride is reduced with Lindlar's reagent to give acetaldehyde in the presence of Lindlar's reagent. So this is the correct answer, right? Then next one, when acetaldehyde is treated with hydroxylamine, the medium should be when acetaldehyde is treated with hydroxylamine. Hydroxylamine. This is hydroxylamine. Condensation takes place. Not aldol, not aldol. The one. Hydroxylamine. Condensation reaction takes place. CH3, CH, double bond, NOH, no? Oxime, no? Acetaldoxime. Oxime is the product. Acetaldoxime. Acetaldoxime. Moderately acidic conditions are needed. Moderately acidic conditions are needed for this reaction. Not highly acidic, not highly basic. Okay, this is very big type question. You try. Complete the following reactions. 2 moles of alcoholic KOH means what you have to do? 2 times you have to remove HCl. Of course, rate of reaction is less. Elimination. Dehydrohalogenation. 2 times dehydrohalogenation takes place. From CH3, you eliminate hydrogen like this. Okay. From this CH3 also you eliminate HCl. So now the B is your CH3 remains present. Yes, this is B. Then ethylene. You have to guess one type of name reaction, important one. You know, Diels-Alder reaction. Diels-Alder reaction. Diels-Alder reaction. So how to get Diels-Alder reaction here? Methyl. Next one is dienophile. Ethylene is called dienophile. Addition for understanding purpose, you can take like this. Cyclization takes place. Ring is obtained. Here methyl, double bond here, methyl, methyl. Okay. 1,2-dimethyl cyclohexene. 1,2-dimethyl cyclohexene. Subjected to ozonolysis. Reductive ozonolysis. So during the reductive ozonolysis, what happens? You break the double bond, attach just oxygen at the doubly bonded carbon. So I am writing this here for convenience. We can get ketone. Okay. Diketone we can get. 1, 2, 3, 4, 5, 6, 7. Think any shortage? I think I did mistake. One more carbon is needed. Like this, no? So 5, 6, 7, 8. One 6-diketone we got. Then that is D. It is subjected to aldol condensation. It is subjected to aldol condensation. Intramolecular aldol condensation. So intramolecular aldol condensation. Okay. Cyclization takes place now during the intramolecular aldol condensation. Heating symbol should be there. I think not printed, no. Heating symbol should be there. That's why 2 mentioned here. So you have to understand. At a time, how can we get the product? During intramolecular aldol condensation, what you have to do? Remove oxygen and 2 alpha hydrogens. Wait. Remove 2 alpha hydrogens and oxygen. Yes. Then between alpha and carbonyl carbon, you put double bond. Here methyl, here COMe, no? This is alpha carbon, this is beta carbon. Alpha beta unsaturated ketone. So this is intramolecular aldol condensation or ketol condensation we can use. So this type of conversion type questions you should do as many as possible. Then only you will apply different types of concepts. Okay, children? Right, next one. Okay, very good. Another type, same conversion type, no options. Very good. This type of conversion type questions you should practice. Complete the following reactions. NaNO2 and HCl at 0 to 5 degrees. So whenever these conditions appear, diazotization of 1 degree amine, you have to think. Diazonium salt is obtained. Diazonium salt, right? So in this case, what happened? This will become diazonium chloride, but that is unstable, undergo decomposition to give carbocation. That undergoes rearrangement and undergoes reaction with OH forming alcohol or alkene. 2 types of products we can get. So first NH2 will go. diazotization takes place. So here N2 plus Cl minus is formed. Okay. But this is highly unstable. As soon as diazonium chloride is obtained, CN bond pair shifted on to N plus N2 gas is evolved along with Cl minus ions, leaving behind a carbocation as an intermediate. But here carbocation will undergo rearrangement because there is a scope for the conversion into relatively stable carbocation. So whenever carbocation formed is just attached to a smaller ring, there is a chance for the ring expansion. You observe how ring expansion takes place. Ring will be expanded. Like this ring will be expanded, no? Pi electron pair is shifted and this carbon making new bond with CH2. CH2. Here methyl. This will get positive charge. Okay, just wait. In another way, we will do the ring expansion. This is methyl CH2 plus. Okay, here imagine C bond pair is shifted onto the next carbon, alpha beta. This will become C minus. So it will become C minus, C plus, CH2 plus. This is just for understanding purpose. I am increasing the steps. Then new bond is formed like this, no, between these two. Yes, this is a new one formed. But again, H minus shift takes place to give the relatively stable carbocation, 6-membered. Yes, that is B. That much of story is there. Now it is subjected to, okay, dehydration. Stable one only we can take directly. So just double bond here, Me here, okay. Then what is happening next one? Ozonolysis in the presence of zinc acetic acid. Reductive ozonolysis, no? Nothing but reductive ozonolysis. So during the reductive ozonolysis, what can we do? Just break the double bond, keep O here, O here. Then one will become ketone, other side will become aldehyde. Yes, ketol is obtained. After the formation of ketol also again, this is C. Again aldol condensation it is showing, right? First, aldol formation with alkali, beta hydroxy aldehyde is obtained, which is subjected to heating. Then dehydration takes place. Alpha beta unsaturated compound is obtained. So now intramolecular aldol condensation. How to do intramolecular aldol condensation? Take 2 alpha hydrogens and aldehyde group. Oxygen of aldehyde and 2 alpha hydrogens. Both are removed in the form of H2O. So between alpha carbon and carbonyl carbon, double bond is created. Okay. So between these two, double bond, right? That's all. That is the product. That is D. Okay. Reaction stopped with this. See how many concepts are there. Many concepts we are applying: diazotization, reductive ozonolysis, aldol condensation, intramolecular. Right. Next one, same type. Complete the following reactions. So here LDA, lithium diisopropyl amide, branched base. Lithium diisopropyl amide. This one. What Pavan? Previous question. First part was a question in the exam. Okay, very good, very good. First part you got the question. Today's question. Diazotization part. Huh? Very good, very good. Means based on the aliphatic primary amine given. Aliphatic primary amine undergoes diazotization first, converted into carbocation that undergoes rearrangement. From the stable carbocation, we can get 3 types of products. One is alcohol, second one is alkene, third one is alkyl chloride. 3 types of products obtained. That is very, very important question, correct? Diazotization of aliphatic primary amine. Okay, coming to this. LDA, this is branched base, N minus diisopropyl, like this, lithium. This is branched base, no, bulkier base. So it prefers to take H plus from less sterically hindered carbon, alpha carbon. Alpha carbon, alpha hydrogen is acidic hydrogen, no? So LDA prefers to take alpha hydrogen from less hindered alpha carbon. So we can get carbanion that undergoes enolization, no? Like this. O minus is formed, that takes H plus forming enol. In this way, enol is formed. Otherwise, you can keep O minus only, no problem. This is O minus. Then what is the cation present? Mo? L plus, Li plus. Li plus comes closer. The next step, what happened? Acetaldehyde. It undergoes nucleophilic addition reaction like this. Lone pair of O minus dropped between C and O. C1, C2 pi electron pair shifted onto C2. C2 carbon becomes carbene ion, attacks at electrophilic carbon, right? This is called nucleophilic attack. Then C double bond O becomes O minus, single bond O minus. Later that takes H plus from water. So what is C? You see here methyl, C double bond O, alpha carbon making bond with carbonyl carbon of acetaldehyde. OH here, CH3. Okay, children, that is the product. Beta hydroxy, alpha beta. This is aldol condensation only, no? Are you observing? Cross aldol condensation. But we are not using OH minus. We are using bulkier base. Next one. This is one side. Other side, what will be happen? Normal base, small base we are using. So when small base is used, what happens exactly in the opposite direction? What exactly opposite in the direction, ma? H plus is removed from this alpha carbon, left side alpha carbon. CO pi bond becomes CC pi bond. This carbene ion, left side alpha carbon becomes carbene ion and attacks at acetaldehyde. So CHOH obtained at the left side one. Two options here now. Two options, either from left side or from right side. OH minus can take H plus from both sides. If it is taken from right side, this is the product. At alpha carbon, which one we have to add more? CHOH, CH3, no? After total working. Same all these steps if you take, what might be C? D already we got, C already we got, no? What might be D? Now here methyl already present. To this alpha carbon newly, which one you have to add? CHOH, CH3 you have to add, that's all. Yes, this is the answer. So this is D. C already we got. This is C. Okay, this is D is the major product with smaller base. With the larger base, bulkier base, this is the major product. This is undergoing nucleophilic addition reaction. So these reactions due to acidic nature of alpha carbon, no? Children? Yes. Okay, you can do this one. Ethyl acetoacetate. This EAA, nothing but acetyl acetoacetate. Acetyl acetoacetate. The presence of base and nitropropene, 2-nitropropene. What will be the condensation reaction? Condensation reaction. Okay, Pavan, are you able to do? Otherwise, shall we do tomorrow? We will do tomorrow. Okay. Trisha, are you doing more? So hint will give ethyl oxide is a base, no? Base can take acidic hydrogen, acetyl acetoacetate. Acetyl acetoacetate. acetate. CO acetyl acetate. That one. Acetyl acetate. So here this is alpha hydrogen, more and more acidic because it is present between two strong electron withdrawing groups. Sorry. COOET, ethyl acetoacetate. Better abbreviation. This is ethyl acetoacetate. EAA stands for ethyl acetoacetate. This is alpha carbon. Alpha hydrogen is more and more acidic. That is taken by ethoxide. So we can get CH minus. To this one side COCH3, other side COC2H5. No? This acts as carbon ion. Attacks at this electrophilic carbon. Pi electron pair is shifted. Okay. Addition. So QT, this side OCH3. This will attack at this carbon. Double bond. Pi bond is broken. One side this group, one side H added. Yes, this will be the plot. 1, 2, 3, 1, 2, 3. During the hydrolysis, ester will undergo hydrolysis to give acid, no? Beta keto acid. That beta keto acid again on heating undergo decarboxylation. First it undergoes hydrolysis. COCH3, beta keto acid. With respect to acid, this is alpha carbon, this is beta carbon. So beta keto acid undergo decarboxylation very easily. Undergoes, of course, heating symbol should be there, no? Then keto group remains present. Yes, CH2, CH2. This is the final product. That is D.